Thank you, Tom, and thank you to all of our 4 speakers, who I think you'll agree have done a very good job of setting out the case for why natural materials in particular have some really fantastic health benefits, both in terms of buildings and the people who live in them. So we'd like to open the floor now if you've got any questions.
Hello. We're building a house with hempcrete sprayed onto a timber frame and with lime plasters. I'd like to know 2 questions really. The first one is, do we have to have an MVHR system? We'd rather like not to if we don't have to. The other point is that we're supposed to have a cob screed over underfloor heating. 1 or 2 people have said that that's very soft and will scratch. And certainly don't use it in a living room space. Could you please make comment about that? So 2 questions.
Okay. Shall I take the hempcrete one?
It's your building. You can do whatever you want with it.
Okay. Yeah, so in my experience, my company builds almost exclusively with hempcrete, and I would say probably about 30% of our clients have an MVHR system installed. One of the advantages, because I spoke to you earlier, I happen to know that you're building in quite a rural location. Okay, so one of the advantages of hempcrete is kind of a good level of air tightness in general in the construction method, but because hempcrete is a mixture of insulation and thermal mass, as well as insulating and keep trapping heat in your room, it's also storing heat in the fabric of the material itself, which means that if it were to become stuffy inside the building, which as the guys have demonstrated this morning is very unlikely due to the passively the moisture buffering within the house. With the hempcrete building, it's perfectly acceptable to open a couple of windows without worrying about losing all of the thermal storage from within the building, because it is actually stored in that thermal mass. So another reason why people would choose to have mechanically ventilated homes is to filter out, particularly in cities, the toxins in the external air, and sometimes for certain people in the countryside that's also an issue if you suffer from allergies which can be affected by local crops. So in summary, it's very much a choice for you as an individual, and those are some of the issues to base your decision. So Rowland, do you want to take the cob floor?
An underfloor heated cob floor. You've just said the dream that everyone's having. If you're concerned about heavy traffic area, then I would say start with it, and then if it doesn't work, think about putting something a little bit harder on. But it only has to be a very thin skin of something else in order to. And it may be that there are bits of the room where there's more traffic and there's less, and you might think about treating different bits differently. I talked to Jeffrey round the corner after this session, if you haven't already, because he's highly skilled and knowledgeable on this. But my suspicion is that in a domestic situation, unless you have wild rave parties on a regular basis, that you can make it quite strong enough for your own use. And then, you know, if it wears a little bit, then you just get a bit of wax and wax it over and maintain it in a normal kind of way, and you'll be very happy. I'm slightly jealous.
Thanks, Rowland. Anybody else? Gentleman here and then a lady over there.
Coming back to your ventilation unit, opening the window is, from a number of reasons, maybe not a good idea, especially in winter. You're losing a lot of energy. So just for argument's sake, I want to actually calculate the performance. I saw the university baths diagram there. My experience as an engineer is that you need high-tech tools to prove that low-tech solutions work. And that makes it very difficult for implementation. So my question is, as an engineer, I need to prove much more stuff. And it's much easier to calculate a ventilation unit, which is a linear process, than a dynamic fluctuation process.
Yeah,
how do we deal with these issues?
Yeah, so certainly in the case of Hempcrete, it's actually it's a very low-tech building method, which is very complex to model what it's doing because it's behaving in, and you would need to use and people who have modeled it successfully have used a dynamic modeling software such as WFI, because it's partly about the combination of insulation and thermal mass, but also about the hygrothermal behavior of the moisture being absorbed, condensing in the wall and then evaporating out again. So I completely agree. And the lady over there, oh sorry, Tom.
Just a point on that, which is it is essential to have, our view on it is that it's essential to have independently verified, backed, scientifically, empirical data to be able to support what you stand up on stage and talk about, or go in front of architects and engineers and specify. The way in which we've approached it is reasonably simple, but from first principles. If take an internal plaster, for instance, we know that 4 mil of it, of our plaster absorbs, 30 grams of moisture per meter squared. And what you can do, if we work with independent, UCAS accredited labs to be able to kind of quantify this, and you can set them through various different regimes to, depending on what your building's usage is like. But that's a material property. And from there, we've worked a little bit with Max Fordham, the engineers in London, to sort of try and then say, well, okay, if that's the case on a meter squared basis, and your project is, you're planning on using 200 meters squared in this room, and your moisture loading is assumed to be this, and because you've got this many people in here doing this stuff, goes back to that graph that we showed about, moisture emission per activity. You can actually start to then get some quite scientifically sound assumptions. On top of that, we've then looked at 2 different scaled down cases of 2 rooms using normal materials and then our materials, and how much energy is required to keep them in a thermally comfortable zone, like what Rowland showed on his slide. That can lead to like 20% energy savings, a moisture buffering material versus a non-moisture buffering material. So there are ways, if we think about it creatively, and work with the right people, that we can empirically derive these elements to give you the data to then be able to do your job to the best of your degree. And so it's about collaboration.
Just quickly to say, if you start with plastic, you know that the absorption is 0. Whereas if you start with lime or clay or timber or straw, then you know that you've already started in a position where there is some absorption. So it's a better place to start, even if I can't give you the science on it right now for your particular application.
Thank you. And the lady in white top.
Yeah, I'm looking at building a house to passive house standards. How does that fit in with the materials that you've been talking about, where you talk a lot about breathability? And obviously passive house is about airtightness.
Yeah, shall I just... It's a really important one that comes up quite often is the concept of breathability, which is the common parlance in the industry for vapor permeability. But because the phrase breathability confuses people and they think about air passage rather than vapor. So the way to remember it is, if you've ever worn a Gore-Tex jacket when you're going hill walking, they talk about Gore-Tex being breathable, which is really about wicking moisture. So it's perfectly possible for buildings to be completely airtight, but also fully breathable, vapor open.
And it comes back to the previous point that if you've got materials which are able to adsorb and desorb moisture, then it takes the pressure off the mechanical system that you might have installed. We had this we had a question before, didn't we, about mechanical systems. Passive House itself is kind of about physics, and so you can build a passive house with concrete and plastic, or you can build it with lime and hemp, right? And Passive House doesn't really have much to say about that directly, but we think that you're better off doing something where the materials are taking the load initially, and then maybe you've got to pick up the last bit of it mechanically, because then you're reducing your reduction. Yeah.
I think we might have time for one more question if anybody's got a burning.
Hi there, thank you. It's more of a comment, but architects, it would be lovely to see more of this in commercial scale developments, and what wouldn't be needed, what information is needed, because it's great, because if it's just a consumer building their own house and they know that's what they want, I can see that that's easier. It's an easy, obvious choice, and they don't need to worry about HVAC and, you know, and you don't have engineers doing that, so it's fine. You just say, oh, that's what I want. But what sort of information? And often, you know, on the larger scales, they're saying, great, we're going to build this thing. It's zero emissions. We've got triple glazing, but they haven't looked at the embodied energy. So they're actually, the embodied energy cost of those buildings will never, the savings in running costs from the triple glazing will never pay for the embodied energy put into them. Once those factors of embodied energy are brought in, which is not regulated for on any government scheme or anything, different decisions may be made. Some architecture practices, like Hawkins Brown, are on the forefront of this, and they are now using in their BIM systems embodied energy for embodied energy values for every single material component. As suppliers and installers, what can you do so that you can provide the information to architects and specifiers, so that really proper, sensible decisions can be made at a large scale that can have a larger impact than just a couple of houses across the nation? I'd like to see what you all have to say about that.
I mean, so is your question specifically more about suppliers, or, I mean, yeah.
I think, so we spend quite a bit of time thinking about how we can give the right information. And I guess actually I'm going to be a little bit cheeky and say it's more of a question back to you. If you're an architect, it's about having the conversation about, so what is it that you need? Now, we can't produce a, white book like, Canal 4 BG or whoever it is, We're working towards that, but there's a huge, essentially you need to know a specification clause, and you need to have the client that has the desire to do it. What we focus on actually is talking about performance and health rather than environmental benefits. As I said, ecological consciousness, fundamentally underpins our business, but what resonates with the market is performance. What resonates with the market, emergingly, but not so much, is health. Now, Well Standard is doing, well in coming into the market, but there's not that upsurge of desire for it. So I think it's a conversation about, we go and stand up in front of lots of CPDs and talk about our products, and we listen to how our product market fit, down to you guys. What is it you need to sort of, for us to say to you, so that we can make this whole thing easier? Yeah.
So that's why we're trying to make organisations that speak for the different supply chains of earth and lime and straw. The information is growing, it is out there. We don't have the same funding stream as some of our competitors who are producing 10% of the CO2 that humans are producing at the moment to make some lovely grey powder, which makes distinctly unbreathable buildings. And I think Tom's point is well made. We actually rely on specifiers to come and specify. We can't specify it for you. You have to come and talk to us about it.
I think there needs to be some push from regulators as well to kind of push, the petrochemical industry is huge, and they've got a lobby on that, and a lot of contractors we work with, they see a barrier in not having the knowledge on natural materials. But if regulators can help, if there's more information provided to regulators, and they can make people make more of an effort to use natural materials, then that will force people to look at embodied energy. And if we can start looking at that bigger picture, contractors will have to up their game, and will have to stop sort of using, I don't know how to use this as an excuse. And a lot of these materials, a lot of it's not rocket science. It's a little bit of a lead, I think, from regulators would really help.
Just to leave it on a totally positive note, which is actually, we are seeing across loads of industries the uptake in interest and adoption of these concepts, be it e-vehicles, be it low carbon materials, be it energy efficient lighting, whatever, insert blank here. And I think it is starting, and the construction sector is inherently slow to react, but it's people that have come to talks like this, and it's people that we go and stand in front of repeatedly in various different, from regulatory, but to just people that want to build buildings out of it, that will create this upsurge, and it will come to a tipping point, because externalities will also help in that as time passes. So we're in a good place, I think.
Thank you. And just to wrap that point up, if I can just mention an organisation who haven't been mentioned so far today, which is the Alliance for Sustainable Building Products, the ASBP. There's actually an unmanned display around the corner showcasing the inaugural ASBP Awards for Sustainable Construction, which I advise you all to pop and have a look at. And that includes a display on their concept of the 6 pillars of sustainable construction, which include not only health and well-being and whole life carbon, but also social value, technical performance. There's going to be 2 that I can't remember off the top of my head, but I think just to reinforce what the guys have been saying, it's about considering the building and the materials that we put into it holistically. It's not, trends come and go. At the moment, health and well-being is the thing. A few years ago it was embodied carbon, but we need to keep all of those aspects of sustainable construction in the forefront of our mind as we're specifying and commissioning buildings. So I think you'll all join me in thanking our speakers this afternoon, and please do enjoy the rest of the show.